Thank you, Rui. Hi, everyone. Though the application of engineering bamboo just starts, it is a great significance to study the connection performance of laminar Voronoi Gridshells. We are interested in grid shells, like Rui mentioned first. And in this particular study, we designed two different Voronoi joints. In the left, we can see a Voronoi joint using a flat grid shell, which is subject to bending. And in the right, we can see a Voronoi joint in a double curvature. In this case, the model will be subject to bending combined with compression. In reality, in a double curvature grid shell, like we mentioned before, we can have joints with bending plus tension and bending plus compression. Bending plus tension is not easy to test. Because of this, we choose to test bending combined with compression. For this initial experiment, we selected door hinges to make the joints, like we can see in these two prototypes, because they are already available in the market. And for the members, we select a commercially available engineering bamboo with thickness of 5 millimeters. We are working in a project design so far, and you are working in a small scale model at this time. We test our lamellas in tension using a specimen 600 long and 96 wide, and a thickness of 5 millimeters, as mentioned before. 3 specimens were tested, and on average, the failure load was 45 kilonewtons, which results in 95 megapascals, which is in accordance with the literature properties we can find in the literature. The failure of the two of the specimens occurred at the clamps and propagate in the longitudinal direction. And in one of these specimens, and here, the failure starts in a cone. And after that, we test the joint in tension. One connection was squeezed, mobilized shear and friction, and the other without friction, only mobilized the shear of the connection. In the load failure, failure in this case dropped to the 2 or 3 kilonewtons, significantly lower than the load found in the tensioned plates. The shear strength was about 11 megapascals with the friction and 9 megapascals without friction. Values is slightly lesser than the literature. Here you can see the shear failure of this joint. In more detail, we can see in this case the shear, like the shear plug. In another case, with friction, the shear plug was entirely detached from the lamella. This kind of the failure, it demonstrates in this paper in the literature like a shear plug and the bleached bamboo. And the other types of failure can be appeared, but in that case, we saw the shear plug. And here we can see in more detail the test we performed in the Voronoi flat joint. The load was applied in the central node and react by the supports of the end of these 3 bars. And we use a cable to reach this frame. The members of this Voronoi joint was flat and 300 millimeters long. Here we can see the model in tested. In this picture, we can see the buckling that appeared. Right, we can apply the load. The load test is about 1 kilonewton, and we cannot break this model because the buckling appeared very in the first load we applied. In this right picture, we can see the final element model in the SAP 2000. Developed by the students, simulating the buckling behavior. But the critical load was higher compared to the experimental one, because the wrong conditions that used in this final element model. In the second Voronoi joint was a double curvature, combined bending and compression. In this case, the member was about 281 millimeters, and the horizon along the horizontal axis. And the force was applied like in the other model in the central node. The vertical load was applied. As occurring in the flat model, the failure was by buckling, and the critical load was slightly higher because the length of the member is lesser than the other, and the numerical result could not simulate the real behavior, again because the wrong condition supports. In conclude with this initial experiment, we could see the potential of the structure application of engineering bamboo for grid shells. Of course, now we can better design and experiment projects using engineering bamboo, especially produced to this application, and use it steel plate joints designed to better perform the connection. We are in a good expectations to collaborate with the colleagues and with the Bambuild startup that can provide our engineering bamboo with for our project. Finally, I would like to express our special thanks to Yuri, Thiago, and Baggio that were the protagonists of this experiment. Thank you for your attention.